Hello, welcome to another episode. In this episode, we are going to talk about angular momentum exercise. As you know that in previous session episode, we did talk about angular momentum. Like I said, in this episode, we are going to break down one of the essential example regarding with angular momentum. Okay. So before that, could you please like, share, and subscribe this channel? That will help me a lot. If you are in TikTok, you can like, share, and follow me. As well as if you are in YouTube, you can subscribe, like, and share with your friends. So let's proceed with this exercise. So it says that there is a kind of two particle, okay? A two particle moving with a constant angular momentum along a horizontal path. The particle one is moving. The particle one moving with a magnitude of 5 points. Five, basically 5 kilogram meter per second, as well as the position vector of a particle one is, I think so, right, 2 meter, as well as this particle is moving with a constant angular momentum along the center or along the axis of rotation. Okay. Now the particle two moving with the magnitude of 2 kilogram meter per second, and the position vector for the angular, the particle 2 is equal to 4 meter from the from the axis of rotation. So it says that what was the magnitude and direction of a net angular momentum. That is what we are going to talk about. So like I said, we are going to break down, or we are going to solve a net angular momentum. Okay. So from this point, for both the particle one as well as for the particles. Basically the from about the point of two particle of the system. Basically for this system, like I said, we have a particle one as well as a particle one with on the angular momentum. So the question is about what is the direction as well as the magnitude of a net angular momentum. Okay, to find out a net angular momentum, basically you need to understand a given term. Okay, so let's take a given term. So we have a given is, we have a P1, which is angular momentum of a particle one is 5, okay, 5 kg per second, okay, and then P2, right? P2 is equal to 2, right? It is 2 kg or 2 kilogram meter per second, okay, and then position vector for this angular moment, for this angular momentum, which is position vector 1, which is equal to then 4, it's 2, right? You can see over here as well, 2 meter, okay, and then r, or position vector 2, is equal to 4 meter, right? 4 meter, okay. This is a given term, okay. Now let's proceed with the solution, okay. In last session, as you know that when we had this guy over here, let's proceed, like I said, with the solution, okay. So in last session, we did describe how to find out the angular momentum of the system, okay. Basically, we can find out angular momentum is equal to L, right? Angular momentum is L or small l, or you can use uppercase L, okay, which is equal to position vector multiplied with a linear momentum, okay. Now which is equal to, you can use 1 as well as 1 to find out linear momentum, angular momentum 1, okay, the magnitude of this momentum, okay. Now you can just plug this term over here, which is basically is 2 meter, right? 2 meter multiplied with 5 kg, right? 5 kg, you can use basically look like this, okay? 5 dots kg and meter square. You can add 0 over here as well, okay? Now, which is equal to, you will get 10 kilogram meter per second, okay? 10 kilogram meter square, right? Basically, the SI unit of angular momentum is kilogram meter square per second, right? Now, this is a angular momentum for a particle 1, okay? Now, to find out the angular momentum for a particle 2, we can use angular momentum is equal to, or 2L, or L2 is equal to position vector multiplied with, basically this guy is 2, right? Multiplied with position vector, right? I mean linear momentum, okay? Now, which is equal to, you can plug this guy over here, which is 4 meter, okay? Multiplied with position, I mean the linear momentum is equal to 2 kilogram, right? 2 kilogram meter per second, okay? Now, you will get that it is basically 8 kilogram meter square per second, right? That is a angular momentum for a particle. So, okay. Now the question is, I just want to let you know the direction of this guy, which is basically it is a counter clockwise, or we can say that into the page. Basically, into the page means is a positive, okay? It is positive. This indicates that the direction is is positive. Basically, you can say a positive, because normally to find out the direction of angular momentum, we can use right hand rule, right? So if you can grab the uh, the particle, let's say particle you have, if you can grab the particle like this, meaning that the right, our thumb indicates the direction. If it is into the page, meaning that it is a counterclockwise, okay? If it is out of the page, which is a it is a clockwise direction, which is out of the page, okay? Basically, that is negative, meaning that this guy is out of the, out of the page, which is basically a, negative. So this negative sign indicates that the angular momentum for this particle is in a negative direction. Okay. Now, what you can do is, the question is about a net angular momentum. So to find out net angular momentum is equal to L1 plus with L2. Okay. Now you can just plug this term over here and this guy over here. Okay, which is equal to angular momentum 1 is 1 10, right? 10 kg meter square per second, right? Plus this guy is negative, okay, which is 8 kg, okay, meter square per second, okay. This is what you need to do. So which is equal to angular or net angular momentum is equal to, this means basically it is 10 kg m square per second minus 8 kg, right? 8 kg meter square per second, okay? Which is equal to positive 2, meaning that is the angular momentum is out of the page, okay? Now, which is, it is out of, basically it's out of, it's a positive, which is basically it is out of the page, okay? Now, you will get that, yeah, 2 kilogram meter square per second, okay? That is a net angular momentum for particle 1 as well as particle 2. So that is all about this episode. Let me know if you have any question in the comment section. I'm happy to reply to you guys. So yeah, that's all for today. And then, like I said, could you please like, share, and subscribe to this channel? That will help me a lot. Thanks so much for your time. Enjoy your day. Have a good day. See you in the next episode. Goodbye.